Hello students, let us derive a relation between the partial pressure in terms of mole fraction. Here we need to do a derivation. So, suppose at a temperature T, three gases enclosed in the volume V. That means here the temperature is taken constant T at the volume V. Three gases are taken. Their partial pressure is P1, P2, P3 respectively. That means if the gas 1, gas 2, gas 3, these are taken in the volume V and the temperature is T is fixed. At the time, the pressure exerted by the first gas is P1, let, and P2 is the partial pressure of the gas 2 and P3 is the partial pressure of gas 3. Let the number of moles of gas 1 is N1, N2 is the number of moles of second gas and N3 is the number of moles of third gas respectively. That means here the three gases 1, 2, 3 gases, their partial pressure are P1, P2, P3 and the number of moles of these gases are N1, N2, N3 respectively. So now we will be deriving the relation, but according to the ideal gas equation, what is the equation? PV is equal to nRT. So what will be P here? From the P will be nRT by V. But in this case, we know that R is constant, T is constant and volume also kept constant here. So there is only change in the pressure. That means pressure, the partial pressure and the number of moles is changing. So for the three gases, what will be the pressure now? That is P1, P2, P3 will be equal to N1 RT by V, that is equal to P1. For P2, N2 RT by V is equal to P2 and N3 RT by V is equal to P3. So like this we have find out the three partial pressure for the three gases at a constant temperature T and the same volume V. So what is the relation we got here? These are the three relation we got here. Let the first equation, this equation we have taken as equation number 1. According to Dalton's law of partial pressure, the total pressure, if these three gases are mixed in a container, so what will be the total pressure? The total pressure will be equal to sum of their partial pressure, that is P1 plus P2 plus P3. So when you substitute these values, that means when you keep these P1, P2, P3 in this equation, so what will be come up with this? Will be getting P total is equal to N1 plus N2 plus N3 into RT by V, because RT by V is common in all these three equations. So we are sum up these equation P1 plus P2 plus P3. So we got the equation, that is the equation number 2. This is the equation number 2. Now we have to derive a relationship between the partial pressure and the mole fraction. So that we are going to do. Now the equation 1 is divided by equation 2. That is this equation is divided by this equation. So what will be getting? That is P1 by P total is equal to, you have to divide the LHS side and also RHS side. So what will be getting? That is N1 upon N1 plus N2 plus R3. RTV also there in the numerator side. RTV is also there in the denominator side. So these one will get cancelled because these are same value. So these get cancelled. So what is remaining now? P1 by P total is equal to N1 upon N1 plus N2 plus N3 is remaining because this part is cancelled here. So what is this part called? This is called as the mole fraction of first gas divided by the total, the number of moles of the first gas divided by total number of moles, that is equal to what? That is equal to the mole fraction, what we have learnt in the chapter first. So that is N1 divided by N1 plus N2 plus N3. This is all together we can written as small n, that is the total number of moles. So n1 divided by total number of moles is equal to mole fraction. So we come up with this value here, that is we come up with the equation, that is P1 is equal to x1 P total. P1 is equal to x1 P total. What is x1 here? X1 is the mole fraction of first gas. So that is partial pressure of the first gas is equal to its mole fraction into P total. So similarly, when we do for the other two gases also, we'll be getting P2 is equal to x2 P total, P3 is equal to x3 P total. So what we can write in the general equation, that Pi is equal to xi P total, where Pi and xi are the partial pressure and the mole fraction of I gas respectively. So this is the relation, that is the relation between the partial pressure and the mole fraction, that is the relation, this relation. So that is an important relation, that is the partial pressure is equal to the mole fraction into the total pressure. So in the textbook, one of the solved problem is there that we need to discuss here. The problem number 5.4, it's a textbook solved problem. In this problem, what are the terms which is given to us? That is, it is talking about a mixture of gases, that is neon dioxygen mixture, and the mass of dioxygen is given and neon, the mass is given to us, that is the given mass. And it is given that the pressure of the mixture of gases in the cylinder is 25 bar, that is 25 bar is actually the total pressure. Total pressure, because we know that P1 plus P2 is equal to total pressure. It is the pressure of the mixture of gases. So it is very clear that 25 bar is actually the total pressure. So we know that according to the Dalton's law, the total pressure is equal to the sum of their partial pressure, that is 25 bar is equal to P1 plus P2, where P1 is the partial pressure of one of the gas and the P2 is the partial pressure of other gas. So we need to find out these. So how we find out this? We know that there is a relation between the partial pressure and the mole fraction, that is P1 is equal to x1 P total. This we have learned the relation. So P total is given to us. Mole fraction we can find it out because the mass is given to us. So we can find out the P1 very easily. So in order to find out mole fraction, we need to find out the number of moles, because what is the relation with the mole fraction? The mole fraction of 1 is equal to, that is n1 upon n1 plus n2. So what is the mole fraction of the second gas will be is equal to n2 upon n1 plus n2. So what actually we need here? We need the number of moles. So first we will be finding out the number of moles. So number of moles will be finding out in this way, that is number of moles of dioxygen, that is the given mass by molar mass. We are already familiar with this formula. Number of moles is equal to given mass by molar mass. So what is the given mass for dioxygen? 70.6 gram. So that is divided by 32. Why it is taken 32? Because molar mass of dioxygen. Dioxygen means O2. We have to find out molar mass, that is 32. So that is 70.6 gram divided by 32 gram per mole. So we'll be getting 2.21 mole. That is number of moles of dioxygen. Similarly, we'll be finding out the number of moles of neon. So that is a given mass by molar mass. What is the molar mass for neon? That is 20 gram per mole. So when you divide it, you will be getting this value 8.375 mole. So we have come up with this value of N1 and N2 here. So what is the mole fraction for dioxygen? Mole fraction for dioxygen is equal to number of its mole, that is the number of dioxygen mole, that is how much we have find it out, 2.21 divided by the total number of moles. That is 2.21 plus 8.375. So when you sum it, so after division you will be getting 0.21 is the mole fraction of dioxazine. Similarly, we can find out the mole fraction of neon. That is number of neon, that is number of moles of neon, that is 8.375, which we have find it out here, divided by total number of moles. So when we solve it, we'll be getting 0.79. So instead of this step, what we can say, we can also find it out this in this way. Once you have find out the mole fraction of one component, how you can find out the mole fraction of other component? That is, subtract that value with 1. Why this we have done it? Because the mole fraction, the sum of the mole fraction of two component in a mixture is equal to 1. Now we'll be applying the formula, that is the partial pressure of the gas is equal to mole fraction into total pressure. So first we are finding out for the partial pressure of oxygen, that is equal to the mole fraction. What we have find out the mole fraction? Mole fraction for dioxazine we have find it out 0.21 into, what is the total pressure? 25 bar. That is given in the question, 25 bar. So when you multiply it, you will be getting the value, that is 5.25 bar. Similarly, we will be doing for the neon also. So what will be the partial pressure? That is P is equal to, P is equal to its mole fraction into the total pressure. What is the mole fraction of neon? That is 0.79. So 0.79 into 25 bar, that is the total pressure which is given. So when you solve it, you will be getting the answer. So what we are getting the answer? That is the partial pressure of oxygen is 5.25 bar and the partial pressure of neon is 19.75 bar. When you make the sum of this and this, that is the partial pressure of oxygen, and when you make the sum with the partial pressure of neon, what should it get? It should get total pressure. So when you make the sum of these values, when you sum it, you will be getting approximately you will be getting 25 bar. So that is about this problem. So in this we have discussed the relationship between the partial pressure in terms of its mole fraction, and we have solved one text problem in this video. So this is all about this video. Have a nice day.